students, by this video let us study about the chemical properties of boron. So boron, the first element in the 13th group, icosogens or boron group family. Boron, it is the only non-metal. Remaining all other metals in the boron group is aluminium, gallium, indium, thallium. So these all are metals except boron is a non-metal. So boron is generally less reactive, but at higher temperature the reactivity is increased. Yes, so this boron, when they combine with other elements, they form boron compounds. Yes, so these boron compounds are electron deficient. They are electron deficient. What do you mean by electron deficient? That means sufficient electrons will not be present in that compound. So those compounds are electron deficient. Yes, and moreover, these boron compounds, they form unusual type of covalent bonding with other elements. Yes, now what is the reason for this unusual type of covalent bonding? Yes, of course, the size is very small. Since boron is the first element in the 13th group, definitely the atomic number is small, and the likewise the atomic size also will be small. Yes, so size is small, and high ionization enthalpy. Yes, so high ionization enthalpy means, what do you mean by ionization enthalpy? The energy required to remove the or break the bond. Yes, so that is called as the ionization enthalpy or ionization energy. So in this case of boron compounds, yes, I mean here a high ionization enthalpy, and moreover the similarity in the electronegativity values. Yes, so electronegativity is the minimum amount of energy required to remove the loosely bound electron. Yes, so that is nothing but your electronegativity. So this electronegativity value is similar in the case of carbon and hydrogen when comparing with the boron. Yes, boron electronegativity value and the carbon hydrogen electronegativity value is similar. So these all are the reasons why the boron compounds are electron deficient, and moreover they show unusual covalent bonding. Fine. Now let us see how the boron react with other metals and they form metal borides. Yes, boron, when they react with any metals, they form metal borides or metallic borides. Yes, so there is an exception in this case. Boron will not react with alkali metals. So you know what is alkali metals? Alkali metals are the first group elements of a periodic table. So you know lithium, sodium, potassium, rubidium, cesium, francium. These are the first group elements of the periodic table. So these first group elements are called as the alkali metals. Okay, so boron show an exception when reacting with alkali metal. It may not react. Yes, whereas boron will react with all other metals in the periodic table. An exception is seen only in the case of alkali metals. So when this boron, formula is boron B. Yes, so its formula, its chemical formula is B. When boron B react with metal, any metal, they form metal borides. Yes, so what is the general formula for this metal borides? That is MXBY. MXBY, where here X and Y, they are the subscripts. Yes, M is indicating the metal and B is nothing but your boron. MXBY. So how these metals react with the boron? How? Yes, so here the combination, direct combination. Yes, it does not require the help of any other enzymes or agents or anything, any other compounds for the reaction. No, only high temperature is required. So generally already it is said that boron is less reactive, but at high temperature the reactivity increases, it becomes highly reactive. Likewise here also, when boron react with metals, yes, the reaction is more in the presence of high temperature, so that by direct combination metal and boron react. Yes, so high temperature. So let us take the example here in the case of chromium and boron. So chromium Cr, when react with boron, N moles of boron, N moles of boron. So N can be any natural number. So chromium directly combine with the N moles of boron and form chromium boride, CrBn. N can be any natural number. So So the formula, so the metal boride, that is nothing but your chromium boride. So generally I said the general formula for metal borides is MXBY, where M indicates the metal and B is the boron. X and Y, they are the any natural numbers. So the value of X ranging up to 11 and value of Y ranges up to 66 or sometimes above 66 also. Yes. So this is the general formula for the metal borides. MXBY, X and Y, they are the subscripts. Okay, the value of X is ranging up to 11. Yes, and value of Y ranges up to 66 or sometimes above 66 also. Yes, so that's it about the formation of metal borides. Yes, so boron combined with the metal by direct combination in the presence of high temperature. Yes, it forms metal boride. So in the case of chromium, when chromium reacts with boron, a temperature of 1500 Kelvin is used here. Yes, so at this high temperature of 1500 Kelvin, boron react with the chromium and they form chromium boride. Yes, so that's it about the formation of metal borides. So in subsequent videos, again you will still see many other reactions involved in the boron. Yes, so hope you